reached the big night. And welcome all you all. I've got a couple of introductions to go through and a few things. This is going to be a night that we should probably enjoy and see some things that most people never ever see in their life. If you're not in any of the Mira Costa Astrophysics classes, you're welcome. You guys, I really am looking forward to this because we're going to see the local group of galaxies, most of them, a lot of them, the brighter ones anyway. We're going to see clusters of stars and all sorts of stuff. We're going to look in between the constellations and see stuff. Now, before I go nuts, Nina is not here. So your chatting is going to be answered by none other than my wife, and her name is Lou, short for her real name. Mrs. B is a real great way to call her. She is a 5th grade teacher over in Felton Elementary School, an amazing teacher at that. But she's here to help me answer things. I can see the chats for once, but I'm not going to always be at the screen. I'll be bouncing around and operating stuff. Okay, a couple things you need to do, folks, to make sure that your grades are acceptable and that you get credit for this. The first thing you need to do is you got to go over to Google Classroom. I'm going to take you there now. Here we go. And remember, who's on the chat? My wife, Mrs. B. So here we go. I am at Google Classroom, and you need to go into the classwork and click on the night lab entrance ticket. It's only available for the next few moments. When I say next few moments, you've got about 15 minutes, and it asks you the normal stuff like last name, first name, and it asks one question about what I'm wearing to verify that you are here at the start. So that's the first thing you need to do. 5 people turned it in one class, and I'm sure in all 6 classes, there's probably 30 people. So get that done now. Go to Google Classroom, take care of that chore. Okay, good. Next, as we go through the night, we're going to be taking care of some other businesses for grades. So let's go back to Google Classroom so you can see what our ultimate determination is as we go and have live views through a telescope or a couple telescopes as we go. All right. So also underneath the Google classwork is an annotated of the Fall Constellation chart. And in it, you will be annotating a chart like I've given you when we've gone over the fall constellations. It's the second last page, or you can click this one. This one's a little bit smaller. And it's due tomorrow night at midnight. So this is the actual 20-pointer that you're going to do as you go through this. You'll annotate it. You'll be listing the objects. You're going to be putting certain symbols. And I am going to show you a completed version right now so you don't freak out. Because right now you're like, I'm trying to get the entrance ticket done, and how am I supposed to take care of this? Okay, so let's go. And again, you can ask questions in a moment. I just want to get you guys oriented in the right way, first of all. So here we go. Ultimately, this is what that 20-pointer will look like. You take and download the sheet, and on that sheet, we'll get as close as we can. You will be annotating all the objects we see. Basically, you use the correct symbol. The symbols are up here. Galaxies are ovals. And you don't have to memorize this because I'm going to get back with you when we do this stuff. There'll be plenty of time. Globular clusters will be a circle with a plus in. Planetary Nebula will be a circle with a plus on the outside. Open clusters will be a circle with dashes in it. And the nebula will either be a square, or if it's a large object, you can actually outline it. So if it was the Great Round Nebula, you would actually make a large area. We've got 1 or 2 of those tonight. So ultimately, this is what you'll turn in for 20 points. Now, I don't want to go too much into it, but ultimately, you have to position the objects we see on this chart. All right, that's the second thing you need to do. I'm going to get to the moment where you guys can take a look. And we can peek, and we got questions to do right now. So, Mrs. Bartlett, what do we got?
Are you wearing suspenders?
Am I wearing suspenders? Do I look? Oh, wait.
I said I'm wearing them.
Oh, boy. She's a funny one. All right. That's a good question. here is me. Am I wearing suspenders? I don't know. I always wear suspenders, but because it keeps my pants from falling down. So I don't know. That is one of the entrance tickets. So you better have a copy because we're going to go for that. All right. What else do you need to do? What? There's more? Yeah. You're off the whole week. You don't have regular class. You're just here for this spectacular night. And you might even notice some pictures over here that are really cool. All right, let's go back to this. And the second to last worry that you have to do, go back to your Google Classroom, is something that will be due the Monday night after the Thanksgiving break. That is the 30th of November. And what you will be doing is you'll be taking screenshot captures of every object we see. If you have a Mac, it's Command Shift 3 or 4. Mrs. Bartlett, is it Command Shift 3 or is it Command Shift 4? To take a screenshot of a Mac. Okay, either one will work. One of them allows you to do the whole screen, and one of them allows you to Command Shift 3. And if you are using a Windows, you need to do the snipping tool. And then always grab a picture. Now, what are you going to do with this? Well, you're going to make it into some sense into a document or Word PDF. So all the information's right here. What will you do? You copy and paste each picture, image, in an order from closest to furthest from Earth. You will label it, obviously, all the objects. And you will also tell me the type of object we're going to see. And I've given you all the answers. You know I do that. And you have to state the brightness, the magnitude for each. And last is the distance. Or not the last. The next thing is the distance. And finally, you have to tell me if it's in the arm, the spiral arm of the Milky Way, if it's in the sparse area, the flat face, if it's in the halo beyond the nucleus, or is it in our local group or beyond. So again, read this. This isn't due for weeks on end, pretty much 2 weeks. In 2 weeks it's due, and it will be a spectacular thing. You just got to know you got to screenshot every picture. All right, I'm blabbing too much. It's hurting your ears. You won't be able to handle this. I get it. So let's get back to me and Mrs. Bartlett. Any questions from the group? F4?
No.
Oh, Command. Okay, good. All right, she'll stop me. What? Okay, so that's the orientation. Oh, by the way, don't leave it until the end because you have an exit ticket asking me what suspenders I will be wearing then. Okay, let's go over what are we doing. Well, I told you what we're doing, but let's look at the different apparati which we're dealing with. First of all, we'll be taking pictures, and this is going right now with something called, well, I don't know, SGP, Sequence Generator Pro. And right now you can see an image of the sky. It is imaging live. Cool. It's black and white. Not so cool. Are there programs that will allow you to do color? Yes. And I don't want to do that because I'm more frequent in using this. I could use Sharp Cap, and I've done it, but yeah, it gets fickled on me. Next, you will find out with this chart where everything's located. Notice the yellow bullseye. It's pointed to one of the arms right over the house the cabin that we're shooting in, right in the constellation of Aquila. Our first object will be here. This is where you get to annotate your objects. Notice the bottom left-hand corner shows you where the scopes are pointed. Right here, here's the scopes, live in action. You might go, Mr. Bartlett, it's black and white. Yeah. In daylight, it's color. At night, it goes to an infrared, and it does it. And it kind of disturbs the images. So if the images get funny, I will have to point the thing away. And last, if we need to, we'll go to Mr. Document Reader to take care of things. All right. So that's what we're dealing with. Remember, constellations, where the objects are located. The actual picture where you will take a screenshot of. And again, I'll be giving you factoids and other stuff and responding to your stuff on chats, which, Mrs. Bartlett, I'm pausing. Any good messages? Anyway, you guys, it's good. And then there it is right here. All right, we're off to the races. It's time to go. We're going to go constellation by constellation. And I am going to go here to show you where we're going. First object, if you could take a peek, is located, and I'm going to type in here, M72. I did it. And then I'm going to say find it. it puts a red spot there, and I will slew to it. Telescope is now moving. You might even see it moving in the bottom hand corner. I hope. It takes a moment. Now, we're pointing at the first object called Messier M72. A word about these things. Messier objects are traditionally known as some of the most spectacular objects in the sky. A French comet hunter in the 1750s, 60s, 70s was, well, kind of put all the objects that could be confused with the poor telescopes of the day. He put them in a chart, and we now know them as Messier objects. There's 110 of them. At the beginning, he only had about 50. Towards the end of his life, there's much more than that, about 103. And then in this century alone, we added a few. So this is the 72nd object. If you want to see it, you should mark it down. It's below the arm of Aquarius, the leg. Here's his head. Here's his bucket. Here's water splashing out. And right down here, you will put a little circle with a plus on it. All right, just to get you guys going, I'll show you right here. So the first thing you're doing, nice Band-Aid, is right below here. I'll put a circle with a plus. I'm not going to do this the whole night. And I'm going to write down M72. This is only worth 30 points. Because ultimately, we're going to see if there's a survey of an organization to all this stuff. Okay, back to here. Take a look what we did. We put it right there. Next, the telescope's now pointed there. I'm now going to go to Sequence Generator Pro, and it has taken our first live picture. Huh? You will, because you're lagging behind me. Okay, she asked, why is the old picture in there? Okay, this is live. This is a globular cluster. Back in the day, the old telescopes, 4-inch refractors were blurry and had chromatic aberration, and I'm taking 30-second exposures. Now, this isn't full resolution. You might say, well, Mr. Bartlett, is this all there's going to be? Hey, just hang on. It's going to be cool. Here's 50%, and here is 100% of its size. Now, a little blurry, and I can adjust the brightness, make it dimmer, and see just the core, or I can actually make it brighter, or I can take some settings. Here's the low stretch. A word on stretching later. Here's the medium stretch. And this is just, kind of a neat thing. So you guys, it is time for you to take your first screenshot. Oh, another image came in. So, snipping tool. Snip it. Copy it. Write down M72. It's a globular cluster in the constellation Aquarius. It's one of the further ones in space. All right? It's in the halo, right? Halo down, meaning it's outside of our galaxy, but close to the nucleus. But it's one of the further ones, 55,000 light years. You need to write that too. So, what are we writing down on this? Once you grab I hope you got stuff to write with. First thing you want to write down is magnitude, 9.3, because you'll be needing that. Magnitude, 9.3. What does that mean? Naked eye is around 5 to 6, binoculars around 10. It can be seen with binoculars, 9.3. Size, 6.6 minutes. Ooh, you're writing all this down? Are you panicking? You're going to have to rewatch this whole live video later. And it's, again, 55,000 light years away. It's not great, but it's one of the more remote ones. Globular clusters are only 200 to 300 in our galaxy, that are around our galaxy alone. There's not many. And that's really cool. Okay, next. I'm going kind of quick. We're going to another object. We are taking a survey of the sky. I'm going to go in here and I'm going to tell the scope to pull up the Saturn Nebula. So next one, Saturn. And look at this. It pops up Saturn Nebula. I click on it. I will find it. Oh, notice where it's at. And I will slew to it. And you will watch the telescope move just a tiny fraction. All right. Once we get to this, I'm going to pause because I know you got questions. Now, I'm going to go over to that other program. Here we go. And in it, Sequence Generator Pro. It is going to now take pictures. In a moment, you'll see this change from M72, the globular cluster, to this weird, bizarre, what is it? Now, don't worry about, give it a moment. It has to refresh itself. We're taking live pictures of a planetary nebula. All right? So stay with me. And in a few seconds, we will see this. These things are real small. The Saturn Nebula. For those people taking notes, again, I will pause after this one. This is a magnitude 7.8. That's brighter than the globular cluster that we just saw. It is not a Messier object. It is a Caldwell object. Patrick Caldwell-Moore came up with another list, but he called it C55. So if you don't want to write the Saturn Nebula, put down C55 on your map. Its size, it's only, get this, it's not even a minute of arc. The other one was 6 minutes. This is 30 seconds by 30 seconds. It looks like Saturn. It's got a bar here. Let's get a, oh, we are 100%. And I can make it a different color. I could dim it out. You might be able to see that bar better. But this planetary nebula blew up, and the central star is still cooking away. It's a white dwarf in the middle. It's quite small. Okay, again, we're going to pause for a moment because you guys haven't fastened your seatbelts. Let's go and put the location for it. So if I go here, the new location, I'll get a little closer for us. As I put it on the chart, you notice M72 was right here. So you will put a little circle with ticks on the end, making it an outside plus for the Saturn Nebula or C55. Okay, Ms. Bartlett, we've started out and we've just done a lot. And I know everybody is quite lost. So I know they got questions. So,
Oh, you got some smarties. No one's asking.
no, maybe they just left. Maybe they'd rather be in class.
I want to leave too.
Oh, my, what?
I'm kidding.
Mrs. Bartlett wants to leave her husband? I heard that. What is that all about? Okay, so remember, these are live shots. The telescope is taking 30-second exposures and refreshing every so often. All right.
I was asking M or N.
M as in Messier. M as in Mrs. or Mr. All right. We have just...
What is C55?
Oh, let's do Saturn. You guys, who asked that question?
Amelia McRae.
Amelia McRae, you get a point. Keep your points and tell me later. I forgot to give you the statistics for all this. Planetary nebula are really close. Usually the ones that we see. Actually, we've seen them quite far away too, but they are small. Magnitude 7.8. Size 30 seconds by 30 seconds. Light years around 3,000 light years. Remember, M72 was 55,000 light years. This is only about 3,000 light years. It's got a low mass star, and it's named after the fact that it's shaped like Saturn. Very good question. You got a point. Remember those great questions. All right, next. We are still in Aquarius, the dawning of the new age. So let's go there. Next on our list is M2. Wait for this one. M2. I'll come up here. The computer does all the work. Plug in M2. And M as in Michael. It's all M. I'll find it. There it is. Notice where you're now putting it. This is a globular cluster. M2. So this globular cluster, you will put a little circle over the back of Aquarius with a plus inside. I am now going to slew it over. The yellow marker will move on over. Nice. Now we're getting the hang of things.
What's the magnitude of C55 again?
Of C55, the Saturn Nebula was 7.8 magnitude. It was brighter. Brighter Daiichi. Good. I hope his computer's working. So we just moved this over. And it's M2. And what is it? Holy. Okay. Okay. See, it's blurry right now. Give it a moment. Give it a moment. Because it moved over and it's going to give me a 36. This is one of those most spectacular globular clusters and one of the largest in the entire sky. In reality, we're not talking about what we see because it's still quite far away. So M2 is another globular cluster in the halo. By the way, Saturn Nebula was pretty much in the edge of the spiral arm in the Milky Way. But look at this beauty. Look at this. I'll change the brightness. Here we go. Dim it out. Look at this. All the way to the center, you can see those stars. Oh, that's gorgeous. Okay, wait, let's get it larger. Let's get 100%. This thing is spectacular. Again, I can change its brightnesses. Let's go high stretch. Oh, look at the size of this monster. All right, information. Magnitude 6.5. This thing is half the size of the full moon. 16 minutes of arc. Remember, seconds, then minutes, then degrees. The moon is 30 minutes or half a degree. But look how gorgeous this thing is. It is known to be naked eye. Even though it's 6.5, some people have said they've seen it in dark skies. In binoculars, I've seen it phenomenal. Big fuzzy spot. 150,000 stars. Don't need to write that down. What was the size? We gave it to you, 16 minutes. What is the magnitude? 6.5. Distance. Remember, M72 is 55,000. This is 38,000.
Can't see it. I think it's frozen.
It's frozen.
We can't see it.
All right. Whoa, what a waste of my time. There it is. Screenshot it.
You see the map, but not the
Okay. Well, I'm talking, that was operator error. It'll be on in a second. Sorry, guys.
Your Lydia Johnson's awesome.
Lydia,
She
get
answers
a
everyone's
get a
questions.
point for that. Okay, so here's M2. Screenshot. Did you get a screenshot of the Saturn Nebula? Hope so. Screenshot this.
Yeah, they can't see.
It's there it is. It popped up. See?
Okay, can you
There-
go over this stuff again?
Yeah, I'll go over it all again. And I wanted to show you how beautiful. One of the lords in the sky. What do you need? 6.8 magnitude. You need a screenshot. I want to show you a couple of things. 16 minutes of arc, half the size of the full moon, and a distance of 38,000 light years. Remember, 150,000 stars. They say the core of this, if you were in the middle of it, it would nighttime would be daytime. I wanted to show you some stuff with it. Watch this. As I go, you can see all the way to the core, all those stars.
Where is M72 located?
M2
M72.
in Aquarius. See, we're all in Aquarius. We've already done that.
Harrison says C3PO.
Harry C3PO, 1 point for the humor. Oh, but wait, well, let me show you this, guys. Look at this. Here's a medium stretch. Oh my God, can you imagine this? Here is a high stretch. This is showing you 150,000 stars. And they also notice it is elliptical. It's not oval. I mean, it's not as spherical as others.
Max McGrail says, wait, 6.8 mag? Oh, yes, Sarah.
Yes,
Sorry,
yeah.
Thank you.
You guys, whoa. All right. So again, every 30 seconds, hands off, hands up, it will refresh itself and get a brand new picture. Boom, boom, boom. There we go. All right. We have gotten 3 objects. I'm going to see if you're doing okay. Let's take a look at what we've got. Give me a second. C55 is what I forgot.
6.5 mag.
So here we go. We watched that for a moment. 6.5, 6.8 is all good.
Do you want to know how many light years again?
That one's 38,000. Okay, on this, little blurry. I don't know why. Maybe if I tap the focus. Ooh, that worked. Now notice what we got. We got 3 objects. Here's M72. It was a globular cluster, circle with a plus. Here is C55, the Saturn Nebula. It's a planetary nebula, PN. And right above the back is M2, which we just saw. Fantastic.
Max McGrail thought you said it was 6.5, but then you said 6.8.
It is 6.8. It's not 6.5 magnitude, but it's not a big difference. So if you were to write that, I would not mark you wrong. Okay, next.
And then Swizz wants to know, where is it in the Milky Way?
M2, M72, the halo. And Saturn, the Saturn Nebula, not the planet, is towards the edge, or I would call it the arm. So you write down arm.
Can you go over all the details for M2 again, Mr. Reed?
No, I will not repeat it. You're going to have to play it again. All right, next, let's see how you're doing.
And is all of Aquarius in the halo?
No, the bucket of Aquarius is not in the halo. No, Aquarius is not in the halo at all. These objects, remember what we're doing? We're looking between the stars. We're going beyond. We're seeing these objects. In some cases, some stuff are in there, like the Planetary Nebula. Next one. I love this next one. Well, I'll be slow on this. Back to where I want to point the telescope. This time I'm going to write the word helix. Not Helix the cat. Helix Nebula. Ooh. I want to find it. Okay. Over to the bottom left. You see it on the screen. It's a planetary nebula. The helix, also known as C63, Caldwell 63. All right, I am now going to slew to it. Telescope will point. You can watch the lower picture in the bottom. All right, there's the Helix Nebula. You got it? Do you know where it's at? Follow the bottom leg. We're not even going to go Capricorn. In fact, Aquarius really isn't fall. And right down there is another spot, helix. Now, I can't wait to do this. There's the telescope. She moved over a little bit. Let's take a look what Sequence Generator Pro is doing. It's taking 30-second exposures. And it's going to come up with our first one. Don't worry about the streaks. That was the telescope moving. That was M2. Screenshot this one. Oh, there. Whoa. Oh, that's 100%. Beautiful. This is also known as the Eye of God on the internet. The Eye of God in 2003, or the Eye of Sauron. This thing is colorful, but you can't tell. Here's a planetary nebula, one of the closest ones to us and one of our largest. And this is the Helix Nebula. It's a planetary nebula. Screenshot it. All right, let's get closer. Full resolution. Oh, dang. This star in the middle blew up. And it was probably about 10,000 years ago it blew up. It's an older one, so it's expanded. It's also a closer one. Magnitude 7.6. So it's a little bit dimmer. The Helix. Oh, dang. Who said oh, dang? I don't. Oh, dang. 7.6 magnitude. Listen to this. Its size is 5 minutes to 12 minutes of arc. 5 by 12. Remember what minutes are? That's half the size of the full moon. This planetary nebula, the star coughed up some gases, and we got this. That's amazing. What else do you need to know? Distance, about 700 light years. Again, when I give you rounded numbers, they're not certain in a lot of cases. Only 700. This is the closest planetary nebula thereabouts to us that we've got. And it is a large, bright one, but because so much light is over the surface area, it makes it dim. I've seen it with binoculars, and other nights I haven't. It's hard to see, but it's really neat.
Yeah. He wants to know, is this not the cat's eye nebula?
No, who asked? Daiichi is not the cat's eye nebula. That's another one. In fact, I think we have to wait for, I don't want to misspeak. It is not the cat's eye. It's the Helix. Where's the cat's eye? Oh, my God. The Eskimos in, I think the cat's eye's in Draco. I think it's in Draco. I could be wrong.
A. Thompson wants to know, is the spiral due to the gravitational pull?
No, who did? Who asked?
A. Thompson.
A. Thompson. August. Well done. 1 point. It is not due to the gravitational pull of us, but the gravitational pull of any of the multiple stars when that thing first coughed up, plus planets, plus the spinning, all sorts of things. Planetary nebulas are bizarre. By the way, this is in the face, right down face. We are no longer near the edge of our galaxy. We're now looking kind of outward. This is C63.
So you wanted to know what's it called?
C63, Caldwell's number 63, or the Helix Nebula. Beautiful. All right, we're still in the edge. And remember, you're seeing this. Look what you're looking at. You're looking at something over 650 years old. That's when this light started and finally got to us. And this is a close one. A star that blew up in a kind of a death thing.
Daiichi found out it was the cat's eye in the north part of Draco.
Woo! Excuse me. I was right about Draco. You get a point for making me feel good. Daiichi, well done. All right, let's take a look at where we're at now. You guys, you should have 4 things. We're going to pick up the pace. Did you get screenshots? Snap screenshots. You need them. You got the location on the chart. We got 4 objects.
What's the mag again?
Magnitude for that was bright 7.6 magnitude, well within binoculars. And I've looked at some nights with binoculars and I've not seen it. And other nights, it's in your face beautiful.
And Harry goes, yes, Bartley, you God.
What? Who?
Harry.
Harry, you get a point for whatever. Just watch your language, okay?
I know, he says, you're God.
That's why I gave him a point, because he said I was the god of the telescope for the moment. All right, my wife, she thinks I'm a god too. So, sorry. Okay, where are we going next? You know what? We're gonna leave Aquarius. We're done.
Lady Johnson wants to know what size. Amelia McRae said 5 to 12 art.
Yeah, 5 to. Okay, if I say 12 minutes, if I say minutes, it's minutes of arc. If I say seconds, it's very rare. I will say minutes most of the time. Okay, and then I'll compare it to the full moon, which is 30 minutes or half a degree. All right.
Johnson wants to know the size.
The size on this again is 15 to 12.
Distance.
The distance was 650 to 700. Again, if you're rounded in, you get a slightly different because I've said different things. They don't know for sure. The range I got down here is 650 to 750 light years. That's how far away.
Paige wants to know, was that a diffuse nebula?
It is not. It's a planetary nebula.
Swizz can't answer the planetary.
Who?
Swizz.
Who's Swizz? Swizz, you get a point for helping. All right, next we're going up to Pegasus, the winged horse. And we've been seeing some weird stuff. And by the way, I got to remind you, you're seeing stuff that nobody else in the world, and especially astrophysics classes, they don't go out and see this stuff at all. You're seeing real stuff live. What?
They wanted to know where it's located in the Milky Way. Milky Way Park.
Yeah, that was in the face.
And Clarkatron, do you mean by plus on the outside labeling a planetary nebula?
Yeah, planetary nebulas are circles that are not filled in the middle with the plus ends on the outside, like a circle with a.
Yeah, Swizz said face.
Yeah. Okay. Next up, I can't wait. Let's go to this weird.
Where is it located in a galaxy?
Face. Yeah. All right. Next, we're going to type in something I love. Another great binocular object is M15 in Pegasus. Let's go. I'm going to go ahead and watch where we're going to go. Woo! Okay, I'm going to get a little bit further away. Here's our drawing. Yes, you recognize this. The Great Square. The Great Square. And there's the horse and the foot. Remember that star? Anybody on that star name? If you get it, first one on there is going to get a point. What that star is, not Markab, not Sheet, not Algib, but that star right near there. We're going to go ahead and slew on over. Watch the yellow bullseye move. Watch the telescope if you can. Slowly move on over. And you're in for another treat, but nothing spectacular. To me, these are beautiful objects. So mark a globular cluster right near the star. Anybody yet?
Let me see.
Enif.
Brooke said Enif.
Brooke, remember your point. Enif. Yeah.
Everyone said Enif now. So.
All right. Who's the first who said Enif? Brooke, and give me the second.
Brooke and Paige.
Brooke and Paige, both get a point. Remember, you're going to have to remember your points when we get back to class in 2 weeks to give those points. All right. I'm writing M15. This is in the halo again. What? Are we seeing a pattern here? Just let's check it out. Now, wait. Right now, it's ugly. There it is. It has to clean itself up. And give it a moment. 3, 2, 1. Even more spectacular than M2 is this amazingly tight globular cluster M15. Remember, it's a 15 object that Messier either discovered, but he did catalog. He may not have. He had a good friend, a competitor who liked to find comets named Pierre McShane, and he may have found this too. But this thing is amazing. First of all, let's give you numbers. 6.2 magnitude, brightest object so far. Can be seen with the naked eye. I've seen it in binoculars many times. It is gorgeous. There's like a triangle of stars around this. This is 100%. Let's go back to the full. Look at it. That's insane. So 6.2 magnitude, 18 minutes of arc. That's bigger than any of the others. 18 and 34,000 light years. So like M2, 38,000, this is 34,000 halo. Got all the information. Good. I want to show you this. Look, this thing is known for having the most compact core of all the globular clusters. 36,000 stars. Remember 150,000 stars for M2? Look at this. Let's get closer. That to me is amazing. How's my wife doing? She wants to leave me again? All right, wait. First of all, watch. This thing is known for having one of the most compact cores. Little blurry on this. I don't know why. I'm looking at the half flux radius up upper left-hand corner, and that means it's a little bit more than I like it to be. But look at this. Okay, wait. Now let me show you some real stuff. Okay.
Aiden wants to know what the magnitude was again.
6.2. That's medium stretch. I'm trying to pull out the log light. And hi, look at that is in binoculars, spectacular. Imagine the diamonds and the fact that your night would be daytime if you're in there. And these are low metal stars. They're massive. Light years. Remember, it's not as far as M2, 34,000 light years away. About that what? The zero star. I don't know. This thing is 175,000 light years. No, I'm sorry. 175 light years across. It's tight around the halo. It's one of the densest known. It is the first it's the first globular cluster to find a planetary nebula. What? First? What do you mean? There are not a lot. There's only 4 known planetary nebula in globular clusters, according to what I read. So that's crazy. But I'm just looking at this and I'm going, no wonder, tense. And remember its location. Pretty spectacular. All right. We're in Pegasus. I hope it's good. Where are we going? Remember, this is on your chart. Next one. I love this galaxy. A galaxy. It is a very similar galaxy to our own Milky Way. So let's go to it. I'm going to type in NGC 7331. I hope to find it. Remember, we're in Pegasus right now.
Cindy wants to know if you can show its location again.
Which one? It is right now. Location's there. Okay. And 15.
And Barry was asking Messier 3?
Messier 15. Okay. No, there's no 3. I don't know where that came from. All right. I'm now slewing to the next one. Oh, I got to find it first. Boom. Right at the top of the head, near the tail of Lacerda. Take a look. We're going up to the top. I hope the telescope doesn't grind away. It's near the top. We're going to move over, and here we go. You're going to write a galaxy. This is an oval in space. Slewing up there. Whoa. Ignore the slew limit. Okay, I hope to do this. Will exceed software imposed slew limits? Yes. Okay, we're going to cross our fingers. It seems to have made it. All right. I'm crossing my fingers. I could have destroyed the telescope right there. All right, where are we going? We're going to go take a peek at NGC 7331, also known as C30. Okay, here we go. I can't wait for this. Galaxies. Now we're in the face again. Face, right? Face. Again, C30. Here it goes. We got 10 seconds. People hanging in there? We got stuff that will amaze you. This stuff is out there now between the stars. And we're doing some, oh, there it is. Okay, I'm looking. Oh my gosh, this is crazy. The mountain has not yet, it's insane. The mountain has not yet stabilized. We got oblong stars, so give it a moment. The next time around should do it. All right, I need to talk about this galaxy. Okay, here it is. Remember, this is NGC 7331 or C30. All right, this is if you ever miss, there it is. Beautiful. Who? I don't know. Not a good time for personal chit chat. But look at this. This is NGC 7331, and I don't know about emails, folks. I've been setting this up all day, so I apologize. So this is a crazy galaxy beyond in our face. We're looking to the face of our own Milky Way. And in it, here's what we're seeing. So C30 is an edge-on spiral galaxy. This is 100%. Do you see the dust lanes?
And Maxwell, I want to know, why does it look like the Milky Way?
Well, because we're in it. We're in the Milky Way, but we're now, what would we see if we were on C30? We would see what our Milky Way looks like. We can't see it. But notice all these fuzzy spots. Here, here, here. Those are faint companions to it. There's supposed to be 4. 1, 2, 3, 4. Look at that. Do you see what's in the upper left-hand corner? Look at those galaxies. I'll give you numbers in a moment. This is Stephan's quintuplet. You can see it. This is live. You guys, I've never seen this live. I've seen 7331 in a telescope before, a 6-inch telescope with eyepieces. But to see this live, to see that big galaxy, all right, take your pictures. This is 100%. I'll stop. I'm amazed. Wait, I'm going to make it a little bit brighter. Look at that. I made it brighter. The spiral, the galaxy. This is amazing. This is, again, okay, numbers. Magnitude 9.3. Size 9 minutes by 2. Why don't I say 2 by 9? It doesn't matter. 9 by 2 minutes. 47 million light years. 47. Hey, the Andromeda Galaxy, which we will see tonight, is around 2 to 3. But I can't believe it. C30, that is that beautiful spiral. Okay, I'm gonna make it brighter again. High stretch. Look at that. This is just one 30-second exposure. I can't believe this. Okay, yeah, I'm losing control. So this is the second furthest out. Again, what do we need? Screenshot. What do you need? Number, either NGC 7331 or C30. Doesn't matter. 2 different catalogs. Magnitude 9.3. The dimensions 2 minutes by 9 minutes, or 9 by 2, and 47 million light years. It's a galaxy like ours. Okay, for those people who didn't get the screen, we'll take a break after Pegasus, but I want to make sure you got this. This is its location again. All right, good. So we're above the head, and you put an oval. All right. For comparison, I got another galaxy for you. Again, these guys are hanging in there, I'll bet. Okay, this one is called NGC.
And then what he wants to do you ever get to see the colors of the nebula galaxies?
Yes, but it takes processing. So who was that, Amelia? Another point. Can we see colors? Absolutely. These are color cameras, but I am not processing the images. I'm not decoding the information in something called a FITS file. But anyway, so yeah, they are in color. And can we see them raw? No, in telescopes you wouldn't see it for most part either, for the most part. All right, 7479. Find it. Fine. There it is. In the tail, another galaxy. We're in the face again. Let's slow down. Oh, it really wants to go down there? I'm shocked. Okay. Now remember, it's got to take a moment. We got to wait for it. We got another galaxy. Can I give you information? C44, 11th magnitude.
I want to know the size and the distance.
Of what? I gave it to him twice. If I give it to you twice, guys, you're going to have to read it back. Oh, okay. This is a weird photo.
9.5.
Huh? 9.3, 9.5 is good. All right, guys, this is a composite of the last image and the image we're looking for. So give it a moment. It's got to go for another cycle. So you got all this weird stuff, stars moving. All right, this C44 is 11th magnitude, arguably the faintest thing we're going to see tonight, arguably. Size, 4 by 3 minutes. Distance, the furthest object we'll see tonight, 98 million miles. Look at that beautiful barred spiral. Another galaxy. We're in the face. We're looking through the face of our galaxy into the depths of 90. What were you doing 98 million years ago. It's taken light 98 million miles, not miles, light years to get here. Let's get full resolution. There it is. Look at that.
Barry wants to know if the gravitational, or the spirals are caused by gravitational force.
Spiral arms, we'll go into the spiral arm information later. There's a bunch of theories about it. There's theories of magnetic fields. There's theories about congestion of like traffic. You know how we go through traffic, it slows down, then speeds up. There's a lot of that. There's star birthing regions in there. There's a lot of problems with it. But spiral arms and why they're different shaped, we'll talk about it later on in the year.
And August wants to know, isn't it a giant black hole?
In the center of galaxies, pretty much most of them do have mega black holes. Take a look at that. You got your screenshot? Good. Because we are in the face and we're seeing all these galaxies. All right. Break for me, break for you. Gonna let it go. Notice where the telescope is now pointing. I'm gonna take a sip of my CocaCola. Is it time for a advertisement from our sponsor? Yeah, right. Like they're gonna sponsor us.
Lane Weston just said, wait, which one is this?
All right, break almost over. 30 more seconds.
Lane Weston wanted to know which one was it.
The one we just saw was NGC 4749, 7479 or C44. C44 is easier to write.
And Mike Hoffman wants to know, how many light years would it take to reach it?
Depends on how fast you go. Because of the dilation that you will experience, you can actually get to, let's say, Vega. If you're going a fraction of the speed of light, you can get there, which is about 25 light years away. You can get there in a couple weeks. What? Yeah, we will be doing the math in our class for that. So that's pretty cool. All right, I'll simmer down.
How many light years would it take to reach it?
That depends how fast you're going. But it's at the speed of light, it took 98 million light years.
And Clarkatron follower asked, NGC 7479.
Yes, or C44. It's a barred spiral. You might have seen the bars. All right.
And I just want to know, where is this?
Location. We always go back to the location, folks. So once I take the picture, break is over, I go back and you can see right at the business end of Pegasus, it's almost like he pooped out that galaxy.
And then wants to know if you could show the annotated paper.
Oh, no. You're doing that. I'm not going to give the answers. I've already given the answers. All right. Okay. I will give.
Top left.
I'll give the annotated version again. Hold on, but I want to cover up a lot of stuff.
Wants to know how long it'll take to get to Andromeda.
Well, how fast are you traveling? Hold on, I'm trying to get this going for you. This is what we've done so far.
And I said right above Pegasus.
All right, okay, hold on. Document reader time. Let me push the button. You guys asked. All right, so what have we got here? You don't have to do M73. That's just 4 stars.
Daiichi even said it's right above Pegasus.
Okay.
2.5 million light years.
This is the last I'm showing.
He's not giving the answers.
I gave the answers. Why do I want to give them again? So we went from M72 globular cluster, where in the arm, we went to the Saturn Nebula, which is in the arm. We then went up to M2 globular cluster, which is halo. So 72 and M2 are halo. We then went to Helix Nebula, which is in the face. I gave you other numbers, so you don't have to write. You can write any one of those things. We then went up to M15, that beautiful, densest globular cluster in the halo. We then went up to that amazing galaxy, C30, which was, what, 7331, which had all the other, it was so far away. And then we finally went to C44, which is your 97, 98 million light year away galaxy, the furthest object we'll see. We're seeing so far beyond, nothing compares. All right.
I want to know which is your favorite star in that cluster.
I don't have a favorite star. I just have a favorite wife. What? All right. Where are we at? We got to go. We got to go into Cetus, the sea monster. Why? Because you know what? We're seeing some spectacular things, but we're not seeing good enough. Nothing that's really reaching us that's going crazy. So
I want to know what is
M2 is a globular cluster. All right, we are now going to Cetus. Where am I going to plot in here? All right, this one is NGC, New General Catalog. That's what it means, just for those people who don't get enough information. And I'm going to plug in 247, and I pray to God we can still see it. Oh, it's going to take a while. Watch the telescope move. Find it. The telescope can't turn over here. It has to go around the world. Watch the screen, watch the telescope as we go for a galaxy below the mouth of the whale. Excuse me as I burped the Coke. I didn't mean to do that.
Wow.
I know. I found it. I'm now slewing. This thing has to flip. Now watch the picture. The telescope has to go all the way around the North Pole, past the roof. How are we doing? Any questions while we are just waiting for things to occur?
Mike wants to know why it's so small.
Because it's so far away. That galaxy actually wasn't small. C44 was actually, well, no, it's small. Okay, where are we? Here we are on the chart. Below the mouth of the whale, Cetus, the sea monster. Below Mars. You mark it down. All right, time to see what the pictures are. Whoa. Give it a moment. Hasn't figured it out yet. All right, notice all that. That was because it was taking pictures as this telescope was moving. Now, the first picture that comes out never is any good because the scope is so massive on this mount that it's just not that good. All right, so here it goes. Check this galaxy out. Whoa, whoa, whoa. Not very good. Wait, got to go another 30 seconds. You can see how oblong the stars are. That's the worst stars I've seen. But you can see the information. Here it is. Galaxy C62.
What object is it?
Galaxy C62. Magnitude 9.1. In binoculars, it was fantastic. Faint. Size 27 by 5 minutes. There it is. Oh, it's faint here. So much of it's over there. This thing is the size of the full moon. The full moon would be about the same size. You could barely see it. It's not real bright. Maybe if I bring this darker. Oh, okay. What else do you want to know? Oh, 12 million light years away. We're moving in. 12 million. This is arguably one of the groups called the Sculptor group. This has been known as this galaxy that maybe the next closest, oh, that's a little bit better, closest to our local group. Now there's arguments because some people say M81, M82 group. The M81 group maybe too. Can you see it? I don't know. Oh, snip your picture either way. Let's see if I can brighten it up.
Where's the glizzy in this one?
Where's the glizzy?
Yeah.
No, okay. The next one I promise is glizzy. Here's the problem. I'm shooting so low in the sky, it's really close to the ski slopes in June. So they're making snow and it's turning this. So take your picture. But notice it's this big. You can see some other fuzzies. Hold on. I know how to make it better. There it is. Now you can see it. This is the full frame view. Do you see it? It looks like a paramecium. Beautiful. All right, what do you need to know again? C62.
And John wants to know, John crossed the mag again.
The magnitude. I'm going over it. Everything. Magnitude 9.1.
Oh, Lydia already answered him.
Lydia's good. Size 14. Give her another point. Lydia, another point.
Swiss said 9.2, so they both had it.
Give Swizz another point also. That's 2 for, 3 for Lydia. Size 14 by 6. I'm sorry, 19 by 6, 12 million light years away.
McGrail said it was 27 by 5.
You guys, I misspoke. The next one's 27 by 5. Oh, all right, you guys. At least you know that this is a group of galaxies that's close to our local group. We haven't even touched one local group galaxy, and there's 8 of them. And you're like, oh, brother. No, guys, this is live. This is real. Nobody sees this stuff. Nobody. It's out there. We're at 7,700 feet in the thinnest airs. I can hardly breathe. Anyway, and there's so little air, and it's pitch dark skies in the eastern Cirrus. All right, no glitz here. How about the next one? For those people who missed it, let me get a little bit higher here.
wants to say 19 by 6.
Yeah, it's
She said, "Oh, I see."
it's 19 by 6. I apologize for getting it wrong. Next one I want to do is one of my all-time favorites. When I saw it in binoculars, my jaw dropped. But notice how low we are. I don't even know if we're going to see it. We better be able to see it. This one is C65 or NGC.
So Daiichi wants to know what's the actual size.
In reality, it's 19 by 6. And it's a spiral galaxy with a lot of crud.
It just wants to know where in the galaxy.
What?
Where is it in the galaxy?
Oh, good question. This one is in the face again. We only see galaxies through the face because there's not as many stars. All right, I want to find this one. Please be there. Here we go. Yeah, the glitz is not there. If we can go there and the trees aren't blocking, to me, this is the amazing one, the size of the moon. All right.
And Parker wants to know, is it 12 MIL?
Yes, 12 million, 12 capital MLYs. Very good. All right, here we go. Let's hope it does a good job on it. I don't know. Oh, did you guys not see where it was? Oh, here's where we are again. I apologize. So you can see the scope in the picture is pointing really low. You might ask, what's that other telescope doing? It's taking pictures of M33 right now. Amazing. I can't show that to you. So we're there. It's below the chin even more. This is called the Sculptor Galaxy. It's not really in Cetus. Here, oh, there it is. Oh, whoo, mama. This is beautiful. This makes me cry. Mama, okay. The lines, forget the lines. Next time around, this is amazing. Okay, there it is. All right.
And Daiichi wants to know where C65 is.
Yeah, I'm going to give it to you. So this is the second largest galaxy besides the Andromeda Galaxy. This thing is the size of the full moon. Let me give you all the information. C65, or I wrote down NGC, there's two numbers, 253. I don't think the other program knows it. Magnitude 7.0. Again, when I saw this for the first time, spectacular. You can see this thing is low to the sky. Size 27 by 5 minutes. It's always minutes. And here's why. It's the group that's closest to us besides our own local group. It's 10 million light years, 10 MLYs.
Someone wants to know, is it C65 or C62?
C65. The other one was C62. Trent, give you a point for catching my mistake. Trent Bark, I had misread the other one. This is C65 or NGC 253. In binos, spectacular. Also known as the Silver Dollar Galaxy. It's 70,000 light years across. Not as big as us.
Tula wants to know why this galaxy is so much clearer than the others.
Because it is a beautiful galaxy. Let's see how beautiful it is. Tula, give you a point. I don't know, but look at that. The stars are big because I'm low in the sky.
Mike has been telling everyone it's C65. He's been telling you.
Who?
Mike Litt.
Mike, give you a point for that. Remember your points, guys, because you come up and you can't remember why you got your points, so I'm not going to give them to you. But look at this. It's a spiral galaxy. You can see it. There's a lot of crud. Not bad for something to be. This thing is only like 15 degrees in the sky. That's looking, but we're at altitude. But I don't know, guys. I just think that this is absolutely gorgeous. All right. We're done with that area. We are now going up into Pisces.
The magnitude,
August, it was 7.0.
Oh, Katrina answered for her.
Katrina, yeah. All right, good. Katrina, give you a point for helping again.
A lot of kids help each other.
Well, you're telling me. So, Mama, okay. Next place we're going to go. We're going up to Pisces. And we're about halfway through the evening. So, guys, that's good. You halfway for in a lot of ways.
Gordon wants to know where C65 is on the map.
There it is. Okay, let's do this again for you, just in case you missed it.
And
Whoops.
Abby wants to know the distance.
Okay, the distance was 10 million light years. And okay, remember that? That was NGC. That's the one we just did. And if I go 247, here's the one we did before.
August, it was 27.
Okay. There it is. So they're the two. Both below the nose. This one's actually in Sculptor, but below the mouth, they're your two galaxies, and they're ovals. All right. Now, the next one is not spectacular, no glitz, but what you will see is truly something that, hey, I've never seen. And it's truly within reason, a good thing. What am I saying? I don't know what I'm saying. I'm blabbing right now. Let's go and see what I have never seen before. First, I need to find it. That's where we're going. So on your chart, another galaxy. We were in the face for the last two. We're still in the face. We only are looking to the face of the side of our galaxy, not the edges, to the face of it, beyond into the depths. All right. I'm now going to slew there in Pisces.
So the fuzzy one was C62 and the one we just did was C65, correct?
Correct. The fuzzy one. The good one was C65. All right. Now, we had just traveled to an area of curiosity. Ooh.
Yeah, Mike Litt knows his stuff.
Twilight Zone. All right. I'm waiting. I got 20 seconds for this to pop up. Remember the size of the silver dollar. God, that's just in the sculptor group. This one, I'll give you a little hint on, this is C51. Write down C51. This one is only 2.4 million light years away.
You might want to take care of this JJ Diaz.
Okay, JJ Diaz, watch your language. Period. All right. That can't happen again. All right, good. You guys can't see it. I can see it. Maybe you can't see it because I need to go there. Here we go. In the middle is a faint, irregular galaxy below Pisces. Little surprise, it's not as good. You might ask, where's the glitz? But it's there. This is 43%. It is this very faint screenshot. Take a peek. And what is it? It is an irregular galaxy in our local group. It was the first galaxy. It's this big, fluffy thing. You can barely see it. Wait, maybe this will make it even worse. You can barely see it. It's that speckling. Again, remember, C51. Magnitude. Whoa, that's not good. Magnitude, 9.3. Size, half the size of the full moon, which is 17 by 18 minutes. Distance, 2.4 million light years. Remember, the last two were 10 million light years and 12 million light years. This one is 2.4. This is really close. This is our local group. You write down no face, you write down local group. No halo, you put local group. It is an oval, you put under Pisces. It is similar to our Magellanic Clouds. Who'd know? But it's a little bit further and it's smaller. The Magellanic Clouds we'll never see. It's in the southern hemisphere. Check that out. I see it, screenshot it. It's in our local group. We can resolve the stars. That's one that nobody ever sees. Where is it again? I show you. That's its location. That's insane. Right below one of the lines. All right. As we're in Pisces, one more thing before we get into the incredible stuff. And you might say, Mr. Bartlett, I got a headache. I don't care. Good for your headache. Next, M74, Messier.
Mike wants to know, is that Draco?
No, that's Pisces. We haven't learned it yet. M74, arguably the hardest. Find it. Look where we're going. So there it is, C51, a local group galaxy. And here's, on the other side, the hardest Messier object to find. I've seen it in a telescope, and I've never photographed it. So this should be exciting.
He wants to know the magnitude.
Of 9.3 was the other one. And it looked faint because it spread out of a lot of area. So we're going there. We'll slew. So mark it on your charts. All right. I'm now going to kick it in. We'll go and image it. And remember, we're going to have the old image at first. So there's C51, that irregular shaped one.
Nicole wants to know the size of C51.
C51 size was 18 by 17. All right. Beautiful. Beautiful. Information. M74. We'll get closer in a moment. Magnitude 9.1. Size 10 by 9. Why am I giving it backwards? Because that's the way I wrote it down. Distance 33 million light years. This is the third furthest object. And it is a grand design spiral. Wait for the next refresher. You'll see how gorgeous this face-on galaxy. When I say we're looking through the face, you can see why. Here it is. Oh, that is sweetheart. Full resolution. Little blurry. Let me break it down a little bit. Because again, I don't want to make it so it's ugly. All right, you can see it. Again, a very well-studied galaxy. Take your screenshot. 33 million light years away, way beyond us. We're looking with spygraph out. Think about it, into the depths of space. You guys are seeing that now into the extreme depths, and look at this, millions of stars. Some information. It's similar to M33, which we'll see next.
Kimmy had wanted to know what was last one, C65 or 63?
No.
It was C63.
No, C51 was the one before it.
Oh,
C51 was that, the 1613.
Kim asked C65 or 62, and Mike Litt said it was C63.
No, the galaxy before was C51 in Pisces.
What's it
The
called again?
65 and 62 were in Sculptor and Cetus area. All right, this one is M74. It is the grand design spiral. You can see how people are there. Stars are there. It's the same size as our Milky Way, period. Imagine putting where we live, 33 million light years. That's insane.
What's the size?
All right, it has two main arms. It's crazy. Again, I'll give you the numbers. Magnitude 9.1, size 10.9, 33 million light years, and we're looking through the extreme beyond depths. We're in the beyond. The one before it was local group.
What was the magnitude?
Magnitude, I just said it, 9.1. All right, now for the excitement. Yes, we've seen other island universes. You know, what were we doing 33 million years ago? I don't know where I was. Cornfields, maybe. Check this out. Here we go. I love this one. This is my all-time favorite galaxy. Now, people like Andromeda, but to me, this is my favorite. Here we go. M33. M is in Messier 33. Find it. This is also known as the Triangulum Galaxy. Local group. All right, you guys got you're annotating your charts. This is due to tomorrow night. Here they are. I got them.
Barry wants to know, are we supposed to have your face in our screenshot?
No, why would you want my face?
And Natalie Collicut wants to know where M74 on the chart was.
There it is. The yellow bullseye is M74. Natalie, M74 is that yellow bullseye right next to Pisces. Remember where the other one was, over here. And then we're now at M33. All right. Get ready for this one. My favorite, and it's in color. I got one in color. I can show it to you later. Could take you a break. I'll give you guys a break and show you my image and color. I can show off, but that's not it. Here it comes. Come on, be good. Why did it not kick off? It should have a long time ago. I'm a little concerned, unless it didn't move. Oh, did I not move it? Did I forget to move it? Yes. What a dimwit. I'm dim. I forgot the slew yellow bullseye.
And Kimmy wants to let you know that the charts are being annotated.
Who?
Kim, charts are being annotated.
What does that mean?
Kimmy heads up. Something's being annotated, I guess. That's Kimmy.
I don't know.
Okay.
All right. We have moved up to the Triangulum Galaxy. And by the way, the Triangulum Galaxy is actually an old galaxy. It was actually mentioned way back, get this, in 2 AD by Ptolemy. Is there a P in front? I think so. And they referred it to the Delton because it was the Greek Delta. I don't think so. All right. Where are we at? My favorite part.
What GPU do you have?
Oh, there it is. Wait. It's not clear yet. I'll talk about GPUs in a moment. Okay, full screen. This is an i7. I made it about 5 years ago. At home, I got the the i9. So yeah, the GPU. I got a 970 graphics processor here, but at home, I got a 24. I got a good one at home, but this is my other home. All right, looks good. This is truly my breathtaking, amazing. I want to show you this with this telescope. What I chose. This is M33, the Triangulum Galaxy.
Paul wants to take a field trip to M33.
Yeah. Who? Someone else took a field trip to M33. One of the Star Trek adventures.
Paris Aquarius going there for Thanksgiving.
Like, yeah, he will be remote. Magnitude 5.8, easily to see with the naked eye. Size, get this, 61 by 36 minutes. That's 2 full moons wide and 1 full moon thick, 61 by 36. And it's now recognized as the furthest object you can see with your naked eye at 2.9 million light years. It used to be somewhat less. I used to say it was 2.4, 2.5. It's like CPR. You've taken it every year. They seem to change something. Well, this is one of them. It is now the furthest object, 2.9. Look at this galaxy. I mean, here's the full resolution. This is in triangle, a little blurry as far as I'm concerned. I'm not happy with it. It should be a little bit tighter than this. But hey, we're moving the telescope all over it again. And for me to refocus it, it would take a lot of doing. All right. Ted Bundy? I don't have Ted Bundy in any of my classes. That's a bogus person. All right, you guys. I told you I want to show it to you in color. Weight, magnitude 5.8, size 36 by 61, distance 2.9. It is naked eye. It's the local group.
And Swiss wants to know light years.
I just did it. 2.9 million. Yeah, it's a spiral galaxy. It's get this. It's half hour size in stars and in size. Hey, it's only 750,000 light years. That's not a lot from M31, which is next.
Wasn't it 9.8 light years?
No, 9.8 million light years. Don't forget the million. All right, you guys, small break because I'm going to show it to you in color. Here we go. Here's an image I posted. I have to type it on in. Here it is. Astrobin, if you want to know where everybody puts their pictures. Ooh, I got some likes. Under Dan Bartlett. I click on it. Wait. Okay, check this out. Check this out. This is the same telescope took this picture. And you wonder about the colors? Here we go. In your face. That is, Mrs. Bartlett. Look how beautiful that is. Look at those star birthing regions, those red hydrogen alpha spots. Look at the old stars in the middle.
Was it 2.9 or 9.8 light years?
2.9 million light years away from us. Look at the spirals. There's a bunch of them. Look at the nebula reflection. Oh, I don't know. I told you guys. Yeah, you shouldn't ask me, is it in color? That's why I goes nuts. Okay, you thought that was great. I got one better. Here we go.
What was the distance that you want to know?
I just said it 6 times.
It's
yeah. All right. I'm not upset at anybody. I'm just saying, all right. M31. The spectacular. Find it right above the knee. You know this Andromeda. You know, by the way, that was the local group. The other one, 74, wasn't. The one before that. Here we go. I'm going to slew over to M31. Wait for this. Wait for this. Wait for this. Again, a little blurry. Not too bad. And you're going to have to wait till it kicks up. All right. That was M31. We just saw an airplane going front. Here it is. The great Andromeda Galaxy. This M33 was half our size. Well, Andromeda Galaxy is twice our size. How much more time? 7 seconds. Remember, the second image is always better than the first because it has to. There's some shaking going on in the telescope, whatever. In your face. Woo! Oh! Yeah. This is amazing. This is the first object ever to be determined to be outside our galaxy. Take that back. This is what was decided, that these were actually island universes beyond our galaxy, not inside. I don't know who that is. So anyway, guys, take a peek. Yeah, we got some cussing. We're going to have to do some moderation. Okay, if it happens again, take a picture. We'll eliminate that person, pull them off the screen, find out who it is. All right, so as we look at this gorgeous thing, there's a lot to say. There's not just one object here. There's three you have to record. All right, number one, this is full frame. This is M31. This one right here, M32. And here, M110. So they're all together.
Where the outer rim was. I'm trying to flip.
Oh, hey, watch. Medium stretch. Do you see the galaxy? Do you see it? It's off the edge. Look at high stretch. Look at this. The galaxy, the arms. Oh, that is just, look at, this is just, this doesn't make sense. Again, M31, M32, and M110. I'll be giving you all the information in a moment. I am trying to enjoy this. Is this in color? Yeah, but I haven't done anything. I'm not saving these pictures. You're screenshotting. This is 100% resolution. I'll blow it up again. That's not even real. But that's live. You're seeing it live. The real. I'm seeing it on my screen. You're seeing it on your screen. That's insane. You could see it. It fills the screen. All right. Information. M31. The Great Andromeda Galaxy. Magnitude 3.4. Size. 3 degrees by 1 degree. That's 6 moons long by 2 moons wide. Again, 3 degrees by 1 degree. That's how big this is. 6 of our moons crosses this. It goes off the field. Distance, they've agreed roughly 2.5 million light years. Remember, the last one, M33, was 2.9. This is 2.5.
Trent Parks wants to know C62, also known as NOC247.
Yes, NGC. All right, continue with that. Just say yes. Trent, was that Trent? All right, that was the information for Andromeda Galaxy. 2.5 million light years away, local group, twice the size of the Milky Way, coming right towards us. It's going to impact us in about 4 to 5 billion years if it doesn't stretch us to smithereens first time.
This kid doesn't get it. It's me,
All right, pull that kid off. Go up here. See if there's a way to remove that guy. Okay. Yeah, we're trying. Okay, we're going to have to do some chores here in removing somebody. All right. So someone's probably not even our class. He may be from the outside world. He might be an alien. Anyway, here it is. What else we know about M31? Let's go to M32. All right, we got stuff to do with M32. M32 is this one over here, and I keep stretching it, so you wonder what I'm doing. As every frame comes in, I want to make sure you see it. Take your pictures. M32, magnitude 7.9, 8 by 5 minutes, and 2.5 million light years away. It's a satellite galaxy. It is a galaxy, again, local group. It is a dwarf elliptical galaxy, and maybe the nucleus of an old galaxy that was ripped to shreds way back when by this behemoth. How do you say it? Behemoth? Behemoth. Big. So that big one.
What was M31 size?
It was 3 degrees by 1 degree. All right, and then go to 110. Check this out. It's beautiful. Another dwarf elliptical, but it's peculiar. It usually don't have a lot of design, but you can see there's stuff in there. You know, guys, I'm just saying this is absolutely beautiful. Magnitude of M110 is 8.0. Remember, 32 was 7.9. Every time it refreshes, you know it's a new shot coming in. Size of M110 was 16 by 10, where this was 8 by 5. Distance of this, it's further away. It's behind it. It looks like it's in front. 2.7 million light years. Okay, you guys, a little bit bigger. Beautiful in itself. Can't believe this. All right, you guys, we're wrapping our way. We're going up to Cassiopeia, and then we'll end in Cepheus. Say goodbye. Did you get your pictures? Yeah, to me, that is the most amazing thing. You guys can see this in binoculars, even from Manhattan Beach. Clear skies, of course. You can still see the core. It is that spectacular. In dark skies, I remember thinking I always saw it nicely until I went to truly dark skies with a pair of binoculars, and it was it filled the view. All right, next up, we're going into last two local group galaxies. I would normally bypass them because we saw that other IC. Remember the IC that we just had that really wasn't good? IC, oh, come on. Oh, I'm skipping too far. 51, it wasn't very good. Yeah, I'll repeat everything, but notice where the telescope is pointing right now. The other one is taking pictures of the M33. The one close to us is looking right out at Andromeda. I will read the numbers again just so you could see this again, because to me this is just medium stretch. I just can't tell you how enthralled I am with this. Okay, numbers that you want to know. Here we go. M32, that's the right one, the one inside. 7.9 magnitude, size 8 by 5, distance 2.5 million light years. It's an elliptical dwarf galaxy, like ours, like large, small Magellan clouds. This one over here is M110, magnitude 8.0, size 16 by 10 minutes. This is half the size of the full moon. Half the size of the full moon, and distance 2.7 million years. Light years.
Do you have to put M32 and then
Yes, you have to put M31, M32 on the chart as well as in your picture book, but they can all be combined. On the chart, you can combine them. Little circles, one on one end, one on the other. All right, we're moving on. I don't even know if this computer's going to tell me this. All right, that was where M31. We are going to go to Cassiopeia. That means we're going up. We're going there. Right in here. We have two more local groups. And here we go. NGC 185.
Did you go over the info for M32?
I just did.
Okay, I'm sorry. This is
No, I know. All right, we're going up there. That's where you want to do. NGC, this is 185 and 147. They're next to each other. So this is M31, M32, and 110 all together.
their distance. You gave them their distance, right?
I gave them everything. Repeat it. And they can always rewatch it too. All right. And I'm not being, I don't want to be harsh. I know, it's hard to do. All right. So right above it, here we go. We're slewing. We're going to two more local groups. These are two more satellite galaxies. Take a peek. Look at this. Wait. Whoa. There it is. Here's the Andromeda Galaxy in the purple. These are satellite galaxies of it.
Did you say NGC 185 or 147?
185 and 147. We got two more. Then we're going to get to different classes. Here we go. Popping up. Okay. Not there yet. Hasn't done it yet. We have to let it do its thing. Give it a moment. We got 17 seconds. All right. What are we looking at? Here's what I want you to put down. NGC 185, 147. They're related. They're satellite galaxies. Put down magnitude 9. Put down sizes. 15 minutes. Oh, I don't see it. All right. Put down local group. They were supposed to be both in the same picture. Never mind. Skip this one. Cross it off, folks. But there is a local group right there. A local group, a satellite galaxy that has drifted off. Do not do this one. I expected both to be in the same field. Here's what we got. Over in here, right next to it, can you imagine these galaxies about the same distance away, but still in the local group? Okay. We are into the last two constellations. And I need a break. I need a Coke break. I think we all do. Time for you guys to catch up with me. I will sip in front of you. You guys ask some questions and I can go ahead and help you out, but I won't turn the camera around.
I don't know if you have some students.
Have we removed?
You have a kid named Sat Anakin. I don't know if he's in there in Ted Bundy.
No, these are random people that are spoofing. So I think we got to figure out how to remove people. So I can do that. And
But I'm thinking,
yeah, we got some cussers, people with foul language that think they're
or speak just talk. No, it's all right.
okay. Well, they're bad chatters,
But
bad
then
chatters.
Well, and you can ask questions regarding astronomy.
Well, I know, but when they use some
Yeah,
cuss
that's
words,
fine.
we got to figure out how to remove people from YouTube. There's got to be a way. Anyway, you heard that talk. All right, where are we at? Cassiopeia. Here we go.
Someone make me laugh, but I can't.
I'm going to type in some stuff and we'll go.
Did we need to label that last one now?
No, do not do 185 and 147. All right, this is called the Pac-Man Nebula. Here we go. I don't know what we're going to see. Pac-Man, find it. There it is. So, below.
Clark, which I want to know, you go over C51 again?
No, not now. He's going to have to play it back later. Okay, so there it is, the Pac-Man Nebula. NGC 281, just go Pac-Man Nebula. This is an emission nebula, so you're going to put a weird gobbledygook wherever that is. We're going to get slew there, away from the group. We didn't need to go. Telescope just moved.
And so we want to make sure you do 185 and 147.
I said we're not doing it.
But you're okay.
We're not doing 185. We're not doing 147. It's because I thought they were both together that I thought they would look spectacular. All right, here we go. Let's take a peek. Pac-Man Nebula, almost. Oh, I don't think this is going to be good at all. I can see it. Wait for the next round. I think we need specialized filter for the Pac-Man Nebula.
We're not seeing the screen.
Yeah, you are.
Tom, it's just your face. We can't see the screen. Lydia says you can't see your screen.
I'm looking.
It's still on your face.
It can't be.
Where are you saying teach?
Is it? No, I'm looking.
We still see your face. Dan Bartlett. Oh, that's on me. My bad.
Yeah, what are you talking about? No, I got the whole thing. There's the Pac-Man Nebula. It's huge. Check this out. This whole thing is it. Do you see the mouth? Do you see the roundness? Okay, this is this is an emission nebula, magnitude 7.4. It may not be that bright, but it's there. 7.4. Its size is the size of the full moon, 35 by 30.
Natalie wants to know what kind of nebula is it.
I'll talk about that in a moment. 35 by 30. This is what you're going to be writing down. It is a diffuse nebula. This is, in fact, what we call an emission nebula, and it's 4,000 light years away. This is in the arm. You see it? Again, repeat. Arm. It is a star birthing area. To see the stars being born there? I know it's not terribly bright. Let's see if we kick it up a little bit. There it is. Better. Even better. Ooh, you can see it though. Stars are being born. I'll give it one more time. I'll repeat the information. Pac-Man Nebula. Magnitude 7.4. Size 35 by 30. That's the size of the moon. If we had the picture of the moon right now, and remember, this is the full size. That's what it is. Holy cow. And it's 4,000 light years away. By the way, there's estimates of some people saying 10,000, but I don't know nothing about that.
Parker said they didn't see the map. Did you already see the map?
Yep, we went to the map, and we're now going back to the map because we're going to get our next one.
Mag for Pac-Man Nebula?
I've repeated everything. You guys?
No, but I lagged, remember?
No, I repeated everything.
Yeah.
So they should have got it twice. All right, there it is. Pac-Man Nebula right there. NGC 281, Pac-Man. Next one is M103. You guys can always play this back when you, and I don't mean to avoid it, but we're just, some of you guys have to repeat it for like third time. That's not good.
On Cassiopeia, is it?
I got it on the screen right now.
It is 281.
All right, there, M103. We're going down to the other side. We were at Shidar right there, Shidar. Remember Kaf, Shidar, and Navi?
Location on chart Milky Way.
Yep, Milky Way, arm.
Pac-Man
Here's
Nebula.
another one. You can see the arm right here. The arm is right here.
So Tula wants to know, do we label it Pac-Man Nebula or NGC?
Either's fine. You could always label it the NGCs, the M numbers, the name. Any of those are good.
Brooke can't see the map. George says we can't see.
Oh, that was my
I
boo-boo.
think your computer's lagging.
All right, let's go back. I'm going back. So there we are, M103. Before, if you didn't get the Pac-Man Nebula, right here, right by Shidar. There's M103. What is M103? It's an open cluster. By the way, you guys, this is like our 20th image. We're almost done. What? Well, I don't want to be done. Yeah, we're getting close to being done. We'll be done in about 10 minutes or so. All right, here we go. Let's go take a look at some pictures. My computer was lagging. There it is. Doesn't look like much. Not so sure I'm that happy with it. Okay, wait for the next refresh. So this is an open cluster. Where is it? Arm, spiral arm, edge. Magnitude 7.4. Size 5 minutes. Distance 7,000 light years. Remember when we were in the local group, we were about 2 million light years. Thereabouts. Now we're in the thousands. I'll repeat it. Here's that open cluster. Take your picture. It's supposed to be involved with some nebulosity. There's supposed to be nebula there. I don't know, maybe a little bit. Doesn't look like much. We're looking into Milky Way. And there's other open clusters. There it is. Beautiful. So, again, magnitude 7.4, 5 minutes of arc, 7,000 light years. In binoculars, there's all these different colors. That star's red, there's blues. It's great in binoculars.
I wants to know the stuff for M103.
I just repeated it.
Like the magic.
Yeah, because of the delay, I repeated it.
Yeah.
Yeah, so,
It's the delay.
okay. So you guys, take your screenshots. Now I'm going to show you something called the Rose of Caroline, or Caroline's Rose. Caroline Herschel, William Herschel's sister, found this one. It is quite beautiful, in my opinion. In my opinion.
Saturn V model is doing. Jack wants to know how his Saturn V model is doing.
Jack Lulich, tell Jack. Hi, Jack. Oops, don't yell that in the airport. Jack, I haven't been to the room at all. I hope it's not even stolen. Where are we going? So, Jack, hi, big hello. We're going over here to Caroline's Rose, which is, oh, I wish there was another number, NGC.
Katrina wants to know, is it a nebula?
No, this is going to be a cluster. Open cluster, NGC 7789.
And Swiss wants to know, are these planetary or disu? Where's M103? Is it IHG?
Okay, here we go again. To repeat, a few of you guys, the yellow is where M103 is. It's an open cluster. And in binoculars, it's spectacular. Now we're going over to Caroline's Rose over here. What is it? I'm going to go slew. It is an open cluster. Discovered. Oh, no, we got to realign. We're on the other side. I didn't know. Look at it. It has to go all the way over there. So, the other one was rough and coarse with different brightness of stars. When I saw this in binoculars, it took me back. There are all these open clusters in Cassiopeia are just some of the most fantastic objects to ever look for. All right. Going to wait for it to refresh. I think we're going to get a lot of gobbledygook. So you guys, on the screen, what you see without the lines is M103. Again, quite attractive in binoculars. Oh, there you go. Next one will be better. There's Caroline's Rose. What do you want to know about it? Magnitude 6.7. 25 minutes. Size of the full moon. Distance 6,000 light years. M103 was 7,000 light years, and it was only about 40 stars. This one is about 150 stars. It's almost like a globular cluster, but no, it's a dashed circle. It's an open cluster. It's an old one because there it is. Oh, that's what she found. And they say it looks like a rose. I don't know, 150 stars. Notice there's no tight condensation as the open clusters. Here's a medium stretch.
I'm not showing it. Let's see. Oh, okay, something else.
You're not seeing it?
No.
There it is. It's my fault. I'm getting sloppy.
Lydia wants to know, what is this one?
So this is an open cluster. I'll read it all over again. There it is. Take your pictures. It's actually kind of pretty. Caroline Herschel found it. Once again, magnitude 6.7, naked eye visibility almost. Size 25 minutes, size of the full moon. and distance 6,000 light years. Sorry about the lag.
8 and I can't see it.
Yeah, we got it fixed. That was before because of the lag. All right, you guys, we're getting into the last little bit of stuff. Let's do this. Let's finish up. We got 2 more left to look at. And then we will bypass Cepheus for another date. And then I want to get... Huh?
What do you call this one?
I call it Caroline's Rose, or NGC 7789.
Where is it in the galaxy? Parker wants to know.
It is in, once again, the spiral arm of our galaxy. And here's its location in the W. We're going to finish up. We got 2 more. And then I want to show you one last spectacular item that you don't have to do. All right, what are we going? We are going to M52. M52, also in Cassiopeia. Check it out. We're going from...
Jack says, Mr. Bartlett, I still have our Messier Object pictures from spring.
Oh, don't tell anybody how good those were. So here's M52. Huh? There's a way up here that you can actually... I don't know who that is. Is he using the cuss words?
No. He's just...
Okay. So we're at M52. What is it? Open cluster. Let's take a peek.
Was 281 an open cluster?
Yes. Open cluster. And there it still is.
Okay, who's my top?
No, 281 was the Pac-Man Nebula.
Okay.
All right, here we go. Magical M52. Wow. That's M52. It doesn't look any different than Caroline Rose. It's a little bit more abstract. Here's the brightness on it, 6.9. Size, half the size of the full moon, 15 minutes. Distance, 5,000 light years. Does anybody see the nebula up here? This is the last one. It's called the Bubble Nebula. So really cool. You guys, we got 2 to do and then we're done. We're going to pull it quits and answer questions. I will repeat anything, but it may mean, well, I better watch myself. I will tell you what we'll be doing and we'll take a look real quick. All right, right here. This is M52. Magnitude 6.9. Size 15 minutes, 5,000 light years. Last one, C11, the Bubble Nebula. It is an emission nebula. You can see it looks like a bubble. It's small though. Do you see it? Half bubble. You can see the half bubble. And that's crazy because there's one star that's got so much wind, stellar wind, that it's just blowing the gas into a bubble shape. So that one is C11, magnitude 11, size 5 minutes by 8 minutes. And distance 1,400 light years. So this one is 5,000 and this one is much closer. That's the Bubble Nebula. So that's about the 22nd or 21st object that we had to do today. We're going to take your screenshots. They're in the same spot, M52.
Cindy wants to know what the LY was. She listed red, Thompson, because this is class. Allison, what was M52's mag?
Okay, I repeated it twice.
No.
But let's do it.
No.
I want. Huh?
I'll show you later.
Okay.
I
We
can
got.
only basically focus chat remarks.
All right. Last object for the night. Well, no. If it gets too hard to do these things, we won't do these things. Just keep them in class regularly. All right, guys. So the last one I want to show you. I know most of you guys are on target, but there's some people that are screwing around, and Ms. Bartlett's having a hard time with that. So, last thing I want to show you.
They act worse than my 5th graders. I got some
Well, they don't get much of a time. I want to go to M45. You guys have heard of it? It's Subaru. You don't have to do this one. This is not to do. Just to say goodbye to.
What is the size of the Bubble Nebula?
The size of the Bubble Nebula was 15 by 8 minutes.
And M52 mag in size?
M52 was 6.9 and 15 minutes.
Okay, and what's 52 and 11, I think was said? And let's see the budget, just size. All right.
All right, last object of the day, folks. Let me pull it up the right spot. Oh, that's cool. It's all the dragging. Give it a moment.
Feeding in or out of my classroom.
What?
I like Dan Bartlett. There will be no fading in or out of my classroom.
What does that mean?
I like the double fade.
All right, so what am I showing you? The Pleiades, Seven Sisters, Subaru. It is a winter object. That's why we're not doing it now, but at least let's look at something everybody's seen in the sky. It's going to be reversed because of the telescope optics. A little too much information, but when you see it, you'll see the Subaru in all its glory. There it is, the Seven Sisters. We stretch it to the medium stretch. You can see the clouds.
You might want to get more practice at this. A for effort, though.
And that to me is absolutely spectacular.
I'm the moderator. You might want to get more practice at this. A for effort, though. Am I the moderator?
Who's that?
Trevelyan.
Yeah. All right. So there it is. Just look at that. We're going to end the evening like this. You don't have to say it. You don't have to write anything about it. But do know that there's another open cluster, one of the closest ones to us. There's a couple more that are close, like the Hades, but this is the Pleiades, the Seven Sisters. Look at the clouds of gas. Look at the dust. In color, it's even more spectacular. Again, it's reversed image because of the type of astrograph telescope it is. But that's the way I want to show you here. And
I like that.
you guys, we're going to call it quits with that last one. I'm going to hang around for a while. Mrs. Bartlett's going to tell me some of the numbers, some of the questions you might have.
Is that Orion?
That is not Orion. That's in Taurus. We'll be doing that. It's one of the fall constellations, but it is the antler or the back of in Taurus. So you guys, I hope you learned something, felt something, saw something that you wouldn't have done in class. Truly, there's some amazing objects. You have a big project, which is putting all those screenshots together. Follow the rules in Google Classroom. Know how to put it together. I only want it in 1 or 2 pages or 3 pages. Put them together, label them, put them in the right order. And yeah, hopefully we'll be able to figure out what the survey means when we do this.
Magnitude for C11, please.
I'll get to it in a moment. So with that, we will be putting together all the information and hopefully understand that you might have noticed that galaxies were in certain areas of the sky. Open clusters were in certain areas of the sky. The globular clusters were in certain areas of the sky. And with that, we'll have some discussion on what it all means. Okay. With that, you guys, at 8:15, that's in 3 minutes, you have an exit ticket to do to get credit. Otherwise, I'll see you in class on Thursday and Friday.
Clark wants to know if you can show the paper labeled map again.
The what?
Paper labeled map, and Mike Hawk wants to know if there's an exit ticket.
Yeah. And it just, Lou, I just said it. I know.
I was just trying to catch up.
Okay. So rough figuring out how to do this. So what am I going to do here? I'm telling you, exit ticket, 2 minutes. Oh, you got to answer the question. What kind of suspenders am I wearing? There we go. Are they light? Are they dark?
Natalie, can you show the chart, label chart, please?
What? How do I do that? Give them all the answers? Nope, the chart's been showed to you guys. I will not show you a complete answer sheet.
And
Why would I
Steve
do
wants
that?
to know the LY for 52.
Okay, I'll answer questions individually in a moment. I'm just making sure everybody's okay. All right, so with that, you guys are free to go. Remember, you have until 9:30 to do the exit ticket. Now, we're going to go and answer some questions.
Thank you, you guys.
Yeah,
Especially Dan Bartlett.
she has to deal with me. I pity her.
No,
And
Dan
that
Bartlett.
person who kept cussing, we got to figure out what to do and moderate that. All right, anybody who has questions other than show me the answers, I'm not going to do that. I'm not going to show you the chart. You guys have been putting that together. So if you have to rewatch the thing, that's due tomorrow night. And then the photo album is due on Monday. Questions, start asking. Okay, you guys, if you've asked and you haven't got answers, ask again.
Swiss, you didn't show us the locations of 52, 11, 45. 12, thank you, you did great, thank you. Swiss says you didn't show the locations of 52, 11, 45.
What? For 11?
I'm reading it.
I don't know what.
You didn't show us the locations of 52, 11, 45.
Yes, I did. And 45 they didn't have to do. So you guys don't have to do 45. I have showed you those other ones. M11. There is no M11.
And don't you want to know where the exit ticket is? I already read it.
Exit ticket is in Google Classroom under classwork. Ooh, wow. That'll space you out. Okay, well, she's taking some pictures. Ask your questions. Numbers. What numbers do you need?
Sydney, is the Seven Sisters a cluster of group of stars?
You don't have to do the Seven Sisters. M45 is a winter object. We'll do that if we do this again.
Okay. And how many pictures of points in the map should we have?
I didn't count them. Initially, there was... Wait. I think I skipped. I'm going to tell you thereabouts. I think you have 21.
Natalie Pelican, did we need to label M33, M32, and M1110?
Yes.
All separately.
Not separately. You had to... What she asked was, do we have to label M33? Yes. That's separate. Do you have to label M32 and M110 separate than M31? No. You could put 31, 32, and 110 together.
Okay, I still don't see the exit ticket, Nina. Swizz, you didn't show C11.
Oh, C11. Oh, yes, I did. It was above 52. So, Swizz, sorry, give you a point for that. It's the same spot on the chart as 52. They're in the same field of view. You can't separate them.
Katrina wanted to know the C11 location.
Okay, again, C11, if it was M11, we didn't do M11. C11 again is right where M52 is. There is an exit ticket that should pop up in moments.
Parker wanted to know where M52 and C11 located in the galaxy.
Yes, arms of the galaxy for M52 and C11.
And Trent's asking about C11 too.
Okay, no wonder why everybody has that question. Good.
And since Sean Laufenberg said the exit ticket isn't in Google Classroom yet, Mr. B.
It pops up always late. Have you ever noticed that? Let's go ahead and take a peek, guys.
Natalie's asking location C11.
Exit ticket, 10 o'clock.
Swiss says you didn't show M52 or C11.
I did. He needs to play it back. Exit ticket appears. Refresh your screen, folks.
Antonio Elliott said Dan. Where's 52 by Swizz?
M52, if you take an extension from Shidar to CAF, one exact length away from it, straight line, you'll find it. All right, you guys, I'll show you to you. Here we go. Here we go. I show you guys. Everybody wants to know C11, M52. I know I did. That maybe I didn't talk about it. I think that's what happened. All right, M52. Here we go. Find it and go to it. We're slewing. So you guys, M52 and C11, the Bubble Nebula, are in the same spot. And again, if your exit ticket doesn't pop up, you have to refresh your screen. It has popped up.
August says I only have 17.
17. Well, let's take a peek.
Clark says, how do you have 21? We only have 18 documented.
18 is perfect.
Clark said, is M72 in the halo?
All right. Shall we do the numbers that we did? For those guys hanging on.
M72 in the halo.
M72 is absolutely the halo. All right, you guys. So here are the ones that you guys will have done. I'm going to read them off. And by the way, there's M52 in the bubble right there.
Swiss says we have 22 documented, 17 pictures.
All right, here are the ones in order that we did. And I'm going to use my fingers to count. So you guys stay with. There's M52. You got it? Good. All right, so here are the ones we did. In order, M72, Saturn Nebula, M2, Helix, M15, C30, C44, C62, and GC 253, which is the Sculptor Galaxy or the silver dollar. Did I use my finger? IC 1612. That's 10 so far. Here we go again. M74 in Pisces. M33. Three of them together. M31, 32, 110. That's 15. I excluded 147, and I excluded 185. Pac-Man Nebula, 103. Caroline's Rose, that's C22. M52, and the Bubble Nebula, 20. Even. Woohoo! All right, you guys, we're going to sign off. If you don't have any final questions, I want to thank you guys for staying in there. Other people, I don't know what's going on.
Now I know how to remove it.
Oh, we figured out how to remove a violator. Yes, you're going to have to show me before we go. All right, gang. So with that, I'm going to go ahead. We're going to sign off on all this. Yeah, there, everybody dropped off. We're going to end your stream and say, have a great night. Oh, I can see people. Tula, multiple pictures have more than one object. That's probably why you have less pictures. Right. You need to have 20 objects, and you can label and have combined objects. The bubble, M52 are combined, and M32, M110, as well as M31. So if you're asking me about pictures, yeah, you have to have an image of each. All right. Where's C22? Oh, C22 was up near. Oh, we didn't do C22.
Yeah, Swiss is asking, where is C22?
No, C22. So we're 19, I guess. All right, you guys. So that's that. Piper, you're very welcome. Thank you for thanking me. So is it 20? No, 19. Did I read off C22? Forgot C22.
Oh,
Okay. Tula, yeah, you guys. No C22. Ferris, you goat. Thank you. All right, you guys. Ending the stream. You guys, will see you in 2 weeks on a Monday. And certainly email me if you have issues. All right. Thank you, Mrs. Bartlett. You were a chore. All right.
Oh, Sophia said, have a nice night, Mr. Mrs.
All right. That was nice.